right, we're going to finish working on the second half of this video, but I did want to show you how to split your screen so that you could pull up the questions on one side and be watching the video on the other. That way, if you want to go back and forth between the two, you can do that. So, however, for the point of this, I'm going to go on with the lesson here and move forward. We're looking at question number 16. And the next question here says, state whether each statement is true or false. We've already done this one. Now the next question. Now we're going to go forward to 20. Refresh. Okay, so I have to refresh and go back in. Okay, started over. So number 16, determine whether each expression produces a rational or an irrational number. So if you think back, by definition, a rational number is a number that never ends, a rational is a number that does end, it repeats in a pattern. Most importantly, it can be expressed as a fraction. So we've got whole numbers, we've got all of our numbers, but most generally that we look at are rational numbers, except for when we think about numbers like pi, square root of 2, square root of 6, square root of 5, things that we can't take the square root of as a whole number. Those are irrational numbers. It's when I write it out, punch it in a calculator, try to simplify it, and it's a decimal that never ends and never repeats in a pattern, then it's irrational. If it does end or it does repeat in a pattern, or it can be expressed as a fraction, then it is a rational number. So looking at number 1, 3 times pi, which we know is irrational, it's going to just give me a really big irrational number, plus 53. So it's still going to be irrational. 2/5 minus 6/10. These are both fractions. If I subtract a fraction from a fraction, it's still going to give me an answer, so it's going to be rational. Now, square root of 6 itself is irrational, but think about what happens when I say the square root of 6 times 2 times the square root of 6. If I was to change the order, the commutative probably allows me to do that, I can say square root of 6 times square root of 6. Well, the square root of 6 times the square root of 6 changes it to the square root of 36. The square root of 36 is 6, and then 6 times 2 is 12. So 12, we know, is a rational number. It can be written as a fraction, 12 over top of 1. And then 1/3 plus 3, we know is 3 1/3, or 10/3. So this can be written as a fraction, so it is a rational number. Number 17. Number 17 wants to know which expressions could be used to evaluate 418 times 27. Now looking at A, this is 418 times, if I was to simplify this, 418 times 13. So I know that's not true. This is 418, if I simplified it, times 27. That works. This is 400 minus 18. That's not going to be 418 times 27, so not that one. 418 times 20 plus 7. That works. That's 27. And 418, this is 27. So that works. Number 18. Which expression is equivalent to 3x squared plus 7x minus 5, all multiplied by 5? We have this quantity being times by 5. So all we're going to do is apply the distributive property and distribute this 5 to each of these numbers inside the parentheses. So I have 15x squared plus 35x minus 55. And see if I find my answers. It looks like it is letter B. So B is my correct answer. So moving on. Number 19. True or false? So if each expression represents a verbal expression, -7 times the quantity triple M minus 11. Think about triple M. Sometimes people think that's the same as M cubed, but it's not. If I have M triple, that means I have it 3 times. So this one is not true. This is false. Because that's m cubed. That is not triple m. Negative 7 minus 3m. That would give us, one thing I would do probably to help myself out with this is I would go ahead and write what this says. Negative 7 times the quantity triple m minus 11. So there's the way that it's worded up here, but we also know that we could distribute this and get negative 21m plus 77. We could write it in expanded form type here, where we say negative 7 times 3m minus 7 times negative 11. So now let's see which of these over here match that. Expression 2 matches, right? Expression 3 does not match because it's a negative 77. And notice ours is a positive. We have a negative times a negative makes it a positive. So expression 2 is true. Expression 3 is false. Expression 4 is true. Expression 5 is false because this is 11, not 77. And of course, expression 6 is false. So let's go through and say it again. We've got false. And then we have true. And then we have false. And then we have true. And then we have false. And then we have false. So, false, true, false, true, false, false. Next question, number 20. We're going to fill in the blanks using the available answer choices. A group of 8 artists plans to attend a pottery class and purchase lunch. We've got 8 people. So it says the expression blank times 10 plus blank can be used to determine that the total cost for all 8 artists is blank amount of money. So we know that we've got 8 people that are going to take the class and eat the lunch. So we take that however much it costs for the class, which is $10, plus how much it costs for their lunch, and times that by 8, and it gives us our amount of money, which is $192. All right, number 21. Which expression is negative 8 times 2m plus 9k minus 13 simplified? Again, we're going to apply the distributive property. Negative 8 times 2 is negative 16. Negative 8 times 9 is negative 72k. Negative 8 times a negative 13 makes it a positive 104. So that makes B my correct answer. Question number 22. What is the value of the expression 4 squared plus 3 times the absolute value of 4x minus 9 when x equals negative 2? So we've got to substitute in that negative 2. So 4 squared plus 3 times the absolute value of 4 times negative 2 minus 9. We'll do what's inside parentheses first. We don't have parentheses, but the absolute value marks act as parentheses because they group everything inside of it together. So I've got negative 8 minus 9, which is negative 17. When I take the absolute value of a negative 17, I get a positive 17. So now I have 4 squared, which is 16, plus 3 times a positive 17 gives me 16 plus, what would that be, 51? 16 plus 51 is 67. So my correct answer is D, 67. Number 23. If x and y are both integers, which expressions or expression are equivalent to the absolute value of x minus 1? Well, I like to just go through and kind of pick some values here. If I look at this, it's looking at all the instances where x is smaller than y. So I'm just going to pick some numbers where x is smaller than y and see which one's true. So x is 2, y is 3. Let's look at it. The absolute value of 2 minus 3 would be negative 1. So if we think about it, absolute value is just saying how far away from 0 is negative 1. Well, it's only 1 unit away. So the answer is 1. So let's plug it in here. The absolute value of 3 minus 2 equals 1. The absolute value of 3 plus 2 equals 5. The absolute value of y, which is 3, minus the absolute value of x, which is 2, as long as x is less than y, my x is smaller than my y. Let's see here, the absolute value of 3 is 3, absolute value of 2 is 2, 3 minus 2 is 1. So far, A is true, C is true. We're looking at the absolute value of 2 minus the absolute value of 3. Well, 2 take away 3 is negative 1, so that doesn't work. And then the last one, the absolute value of 3 plus the absolute value of 2 gives me 5, so that one doesn't work. So A and C are my correct answers. A and C. Number 24 says, a store scale measures the weight of objects within 0.4 ounces of the actual weight. That's kind of useless information, really. That's just thrown in there to throw us off. The store scale measures an object with an actual weight of X ounces, displaying 7.2 ounces on its screen. Which expression, using absolute value, shows the distance the actual weight is from the weight shown on the scale? So the actual weight subtracted by the distance that it is, which is 7.2. So we end up with the correct answer being the first one. The absolute value, because we're looking at the distance between those two numbers. This gives me a distance. Number 25. Fill in the blanks using the available answer choices. Use the expressions in the table to answer the questions. So it says that which expression has the greatest value when x equals 1 and the least value when x equals negative 4. So what we're going to do is we're just going to plug in 1, and evaluate each one. This is a little bit of work, but not hard work. Hopefully we can do this in our head. 1 cubed is 1. 1 take away 11 is negative 10. Absolute value of negative 10 is 10. 9 plus 10 is 19. 19 take away 4 is 15. So when I plug in a 1, I get out 15. If they didn't do that too fast. Look at the next one. 5 times a 1 minus 8 times the absolute value of 2 minus 7, which is negative 5, plus 2 times 1. So they told me x equals 1. So 5, and then minus 8 times the absolute value of negative 5 is a positive 5, so 8 times 5 is 40, plus 2, that gives me negative 35. Negative 35 plus 2 is negative 33. Is that correct? Okay, my next one is, let's see here, 6 minus 2 times 1, absolute value of 10 minus 1 to the 4th power. So 10 minus 1 is 9, 2 times 9 is 18, 6 take away 18 is negative 12. And my last one, negative 1/3 times 18. Well, I know that's just negative 6. A third of 18 is 6. Okay, plus 7 times 1 is 7. Plus 7. Minus the absolute value of 7 times 6 is 42. Oh, wait a minute. 6 times 1 is 6. 6 take away 5 is 1. Absolute value of 1 is 1. So negative 6 plus 7 is 1. 1 take away 1 is 0. So it says, which expression has the greatest value when x equals 1? Obviously, that is going to be this one. Has the greatest value, A. Okay, so let's choose my A. Okay. Part 2, I've got to plug in negative 4. So we're going to do all of that work again on this time, plugging in a negative 4. 9 plus the absolute value of negative 4 cubed minus 11, take away 4. Well, 4 cubed is the same as 4 times 4 times 4. negative 64 times 4 times 4, negative 64. Negative 64 minus 11 is the absolute value of that. I believe that's 75. So 9 plus 75 minus 4. So that gives me 84 minus 4, which is 80. Okay, so we've got 80. Plug in the next one. 5 times negative 4 gives me negative 20. Negative 20 minus 8 times 5, which is 40. Plus 2 times negative 4, that gives me negative 20. Minus 40, which is negative 60. Minus 8 is negative 68. Let's kind of look at the least value. So far it's looking like B, not A, obviously. Keep on going. 6 minus 2 times negative 4 times 10 minus negative 4 to the fourth power. Negative 4 to the fourth power is 256. So 10 minus 256 would be negative 244. So when I take the absolute value, I get a positive 244. So 6 plus 8 times 244. Negative times negative makes it a positive. So I'm going to get a pretty big number right here. And then when I do 6 plus that number, I get 1,962. Now that's looking like possible number. Let's think about this one. We're going to have a negative 6. This is going to be another negative. 7 times 4 is what, 28? Negative 28 minus 6 times 4 is negative 24, negative 29. Is anything else? Positive 29. So these are all negatives. So it's going to be a bigger negative. So my correct answer has to be C, because we're looking for, oh, no, I'm sorry, I'm crazy. We're looking for which one has the least value. Right? The least value. And it is C, because this is supposed to be negative. Let me go back. Maybe I messed up here. I made a little mistake, which is part of the process. So I had to go back and figure out where I made my mistake. It's called analyzing and fixing the mistake. Remember my how to learn math wall. But anyway, when I plugged in my negative 4 on this top part, I got 80. Then when I plugged it in on the next one, I got negative 68. All of that was okay, but I made my mistake here. I said it was 1,962. It was actually 1,974. But I didn't make my mistake when we were doing it together. I made my mistake when I worked it out earlier on my own. I did a negative times a negative and left it as a negative. And a negative times a negative is a positive. So anyway, that was where I made my computational mistake. Okay, so then the last one we got was negative 43. Okay, so now it asks me which expression has the least value when x equals negative 4. So what is the least value? Well, that would be B. My correct answer is B. And so part of what was making me doubt myself is the McGraw Hill. I found several mistakes as I've been working through this program. But they had made a mistake. They said the correct answer was C. And so that justified my negative in a negative intention. So anyway. They must have made the same mistake that I did. So you can see that even math people that do it every day, make mistakes. That's okay, as long as we learn from those mistakes and we analyze and fix those mistakes. All right, so looking at the next one. The absolute value of negative 4, we know is 4. The absolute value of negative 4, well, that's the absolute value of positive 4, which is still 4. So, it's asking me the answer to it. Let's plug it in. Absolute value of negative 4 is 4. Absolute value of 4 is 4. The negative absolute value of negative 4, I evaluate the negative 4 first. The absolute value of that is a positive 4. Then I attach that negative, so it's negative 4. Same thing here. When I evaluate this, I get a positive 4, but then attaching this negative outside of here gives me a negative 4. Next question. A baseball player's secondary average is a way to look at his extra bases gained without regard to his batting average. The formula for SECA, secondary average, is T minus H plus B plus S minus C all over A, where T is total bases, H is hits, B is bases from balls or walks, S is stolen bases, C is the number of times caught stealing, and A is times at bat. So it wants us to calculate these really quickly. Let's just look. It's nice because it goes in order here. T minus H plus B plus S minus C, all of that is divided by A. So we can go through and just type all this in the calculator if we want, or we can do mental math in our head, however you want to do it. But I will pause the video and take a second to do the math. That way you can check my work. Okay, so when I calculated this, I got 0.39, 387, and I rounded up to 39. I got 0.282, I believe it was, and I rounded to 0.28. This one is 0.5. And my last one, you can't see on my page, but it is 0.31. So I'm going to scroll down here to Uranus and get 0.31. Now, part B says, how many additional times at bat for which a player does not get on base affect his SEC? Basically his, what's that called again? His secondary average. How would this affect his secondary average? Well, let's think about this. So his number of times at bat is A. So the bottom number is getting bigger, but he doesn't get on a base. So B is for bases. So we're adding a smaller number on top. Well, let's just think about that. If I have a smaller number on top, let's say 1, and I have a number on the bottom, say 7. When we add to that number on the top, or we don't add to it because he doesn't get on base, we keep it 1, but he bats again. And I got 1/8. Think about this. He gets up to bat, he doesn't go to base, so that number stays the same, but now his batting average is getting even, or his number of times up to bat is getting larger. So if you look at this, these fractions are getting to be large, have larger denominators, which actually means that they're smaller pieces. Think about, or smaller fractions. I always like to think about pizza when I think about fractions. If I'm one person splitting my pizza with 9 people, then I'm going to get a bigger piece if I split with 9 people or with 8 people or with 7 people. Obviously, the fewer people I share with, the bigger the piece I get, because the more people I share with, I have to cut my pieces smaller and smaller. So we can see that these numbers are getting smaller. This is 0.125. This is a little bit bigger. I don't know exactly what it is. 1 divided by 7 is 0.14. And 1 divided by 9 is 0.11. You can see this is getting smaller and smaller as it goes. Think about 1/2 of 0.5. That's way up there. So the more times that he goes to bat that doesn't get on a base, the worse his average is going to be. So let's get down there and plug in our answers. It's going to lower his overall average. And that makes sense. You know, if you go up to bat and you don't get on a base, that's going to lower your average. All right, number 28 says, Amy wants to earn enough money to buy a car this month. If she earns $8.25 per hour, and she expects to spend $2,000, how many hours should she work? Well, if we plug each of these numbers in, we can see that this one gives us the correct answer. However, have you ever heard tell of somebody babysitting for 242.42 hours? Yeah, you get paid by the hour. So if she works 0.42 with an hour, they're going to pay her for a full hour. And they're not going to just say, work for so many hours and then I'm just not gonna pay you for that 0.42 parts of an hour that you work. So we know that this is not a reasonable estimate. This is the exact answer, but it doesn't really make sense in terms of the problem. So if it's 242, we know that that's not going to give enough money. 240 is not going to give enough money. So the proper answer for this type of a question would be 250 hours. Teaching a babysitter around 250 hours to have enough money to get her car. All right, next and last question. In 2014, global revenues for digital music were reported at $6.85 billion. Select the option that best describes the accuracy of the report. So with this report, they're saying $6.85 billion. That is not an exact number, which is good because they're talking about global revenue. $6.85 billion is an estimation. And this is a pretty accurate estimation. It's not like they're saying $685 billion, 276, maybe, I don't even know how to say that number that I'm trying to say, but they don't give you some big crazy number, like all the way down to the dollar. They rounded it to the nearest billion. So that's a pretty accurate estimation because it's not too, trying to think of what the word I'm trying to say here is. It's not too specific. It's vague enough, saying it's 6.85 billion, that it can represent the global revenue. All right, so hopefully that made sense. This is all that I have. Please make sure that you are studying. I will pull questions from your study guide for the test. I might change the numbers just a little bit between here and there, but if you know how to do these 29 problems, you will be able to pass